All right, let's go ahead and get started. So our first problem was the classic binary search problem. So did anyone want to share their solution for this? I guess probably everyone's solution probably looks the same. So you can just go through this one. So given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If it exists, then we return its index. Otherwise, we return -1. And the key point of this is that we want to write an algorithm with O of log n runtime complexity. That gives us a big hint that this is probably a binary search problem. So we see in this test case, we have nums and target, and we are searching for 9 in this array. So we output 4 because that is the index of 9. So for my code, I define two variables, L and R. L starts at the first index in the array, and R starts at the very last index. And then I have this variable mid, which is adding together L and R and dividing that by 2. So that gives us the midpoint of the current array, subarray that we're looking at. And then if the number that we are looking at is less than the target, we want to move our subarray to the right. So we're going to increase L. If it is greater than the target, then we want to move our subarray to the left. So we're decreasing R. And otherwise, we are at the target. So then we return the current index that we're at. And if we never find our target, then we just return -1. Sound good? Makes sense? Nice.
Hold on.
Why, thank you. And this
I can do that in Discord. I can do it now.
Yeah, you can clap. So this problem was pretty much, I think maybe we should have chosen a different problem. This one is like the exact same problem, except we're returning L at the very end. So this problem is search insert position. Given a sorted array of distinct integers and a target value, we return the index if the target is found. If not, then we return the index where it would be if it was inserted in order. So tracing through this, if we were to trace an example, you would see that L ends on the position where we would insert the target if it's not in the array. So we return L at the end, and the rest of the code is exactly the same. Did anyone else do this differently?
Where do I find these problems?
They are under announcements. Yeah.
Yo, I'm only gonna be here for like 10 minutes.
What was that, Daryl?
That was Bill.
Oh, hey, Bill, how's it going?
Good. I have class in like 10 minutes, but I just want to see what's going on.
Nice. Did you do any of the problems, Bill? The weekly problems?
What?
Did you do any? Hey, Mitchell. Howdy.
Wait, where can I find that?
You can find all the, so each week we do a set of problems, then we go over our solutions together on the weekly meeting. So you can find the problems that we did this week under announcements in Discord.
Okay. Okay, I see.
Okay. All right, this problem gets a little more complicated. So search in rotated sorted array. There is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index, such that the resulting array is then rotated. For example, this would be rotated at pivot index 3. So starting here, and it would become this array. So given the array nums after the possible rotation, return the index of target if it is in nums, or -1 if it's not in nums. All right. So here's my code here. Start off similar to the simple binary search problem with L and R starting at the beginning of the array and the very end of the array. And then we calculate mid the same here. And if on this current iteration, nums mid is equal to target, then we're returning mid because we found the index that the target is at. And this is where it gets a little more complicated. So I have an if statement here that is detecting when we're in the left sorted, when mid is in the left sorted array. So when mid is somewhere in this array. So when we're in the left sorted array, we either want to shrink the array to the right or to the left. And our way of detecting if we want to shrink to the right is if target is greater than the current the current number that mid is at, or if target is less than where L is, then we're going to shrink the array to the right. Otherwise, we're shrinking the array to the left. And then in our else statement here, this is when we are in the right sorted array. So here, in this array, we're shrinking the array to the left when target is less than nums mid or target is greater than nums of R. Then we shrink to the left. Otherwise, we shrink to the right. And then at the end of that, if we never find target up here, then we return -1. And yeah, that is login runtime and constant space. Any questions on that one? Sweet.
Wait, hold on. Can you
Yes.
conceptually explain the whole part of like the if target nums mid or target less than nums left, like that whole part, like how to check the left sorted array and right sorted array?
Yeah. So here, let's say L is at 0 and R is here at
Mid's like 7, right? Mid
6.
7.
Yeah, then mid would be 7 here. So we see that nums L is 4 and so it is less than nums of mid, so then we know we are in the left sorted array. So that would also be true if the array wasn't sorted, like up here. If this was our mid, this was our L, and this is our right, then we're considering that like we're still in the left sorted array, even though it hasn't been rotated. And otherwise, let's say nums of L is greater than nums of mid. So let's say like mid is here and L is over here. Then we know that mid is in the right sorted array because L is greater than it. Does that make sense?
Because I get like you're in the left sorted array, like
Yeah.
how is that like?
Left side, the right side, yeah, based on how they, which one's greater than what's the. So if you look at left and nums mid is greater than, we can determine the rotation does occur in this space.
Oh, so like mid's always gonna be the middle point there. So you're like so if you look at 7 and 2,
Mm-hmm.
and then you look at 4 and 7, you just say like, all right, well then we're in the left point or right point based off of like here. And so 2 is so right is less than mid.
Mhm.
You're in the right point.
Yeah, exactly. Yeah, this problem honestly confuses me too. Like it takes a while to get that conceptualized correctly. Doesn't come to me naturally for this problem.
I think there was like another approach that you could do. I think Mitchell did it too. Where you first find the pivot point by finding like the minimum element. So like there was like another problem, like it was the optional problem where you had to find the minimum element in the array, and you would use that as your pivot point. And then you basically like you choose between, you know, the two subarrays, whether your target exists.
Oh,
in the left array or the left sorted array or the right sorted array?
You're cutting out a little, Daryl. Could you repeat what you just said?
The whole thing,
Just,
everything.
just at all. Do you want to show your solution,
Yeah.
Mitchell, so that we could see that?
I got this, yes, I guess what he's talking about.
Yeah, you could.
Screenshot.
Yeah.
Am I still cutting out?
Oh, now we can hear you.
Okay.
Screenshot or copy paste.
Yeah, but the idea
Um,
is
Let's do screenshot, please.
It'll be
yeah, but the idea is you find your pivot point just by using the index of the minimum element in the array, right? And once you find your pivot point, you basically have like the split between your left subarray and your right subarray. And then you just decide whether, okay, you know, where is my like target existing?
yeah, you can find out.
So if you can find your minimum element in log n, you could also find your target in log n. It's the two pass solution. Yeah.
Yeah, maybe you should. That's okay. Next time we'll know the text. There we go. Perfect. Yeah.
All right. See you, Bill.
Oh, see you, Bill. I didn't hear Bill.
Yeah, he didn't talk. Bro, I feel like those binary search problems that we did during the blitz were a lot harder.
Change it to Joseph.
Thank you. Oh, nice. There we go. Okay, so this is where we find the minimum value in the array. So that's where it's been rotated, essentially.
It's actually the technically the greatest value, I think.
Oh,
I
okay.
I think it's, yeah, built up to the. So yeah, I did, and I put in the plus one, so yes.
So it'd be like at 7.
Yeah, and then
Okay.
plus one gets to 0.
Okay.
You look at my the output of search.
What's the runtime on this?
Log.
Yeah, so you have like multiple login algorithms.
Yes, technically 2 log n. Doesn't really matter.
Nice, cool. It's cool to see it a different way.
It's basically the same thing, it's just a little bit more separated. We kind of ended up doing both at the same time.
Yeah. Yeah, but it's the same complexity overall, so nice.
Wait, so what yours does is it just checks, these are both 2 login, so these are both 2 login?
Well, mine,
Yours was like, it checked the left side for the target, and then after that, it checks the right side if it's not on the left.
yeah,
Which is actually still log n.
I think,
Yeah,
The operation time.
It's still log n.
yeah, I think it, yeah, it would simplify, but it might be 2 login, the same as his.
Well, that's the same as. Yeah.
Just log in. So it's just one pass,
You could
yeah.
just log n and then the operation time side could be longer, which again, all of it doesn't really matter, it's all within.
Yeah.
So. What do you use the pivot for? The pivot it's passed into search where it uses that as the bounds. I am looking at my country, but I did. So just split up the array in 2 and then check some searches. Yeah, if you look at what search takes in, right is left is the pivot plus 1, and right is the last index, right?
Okay.
I guess, yeah. But what does both does, it actually does both. It does search with 0 to the pivot, and then search from pivot plus 1 to the end of the array. And then
Nice.
both. Fire. So I put it to 2 sort of array type search those. So, and so it's not, so the first one, if I return a -1, I didn't find it. So then we have to check the other half. And if both are -1, then it's not there. But one of them is then.
How about you could find the minimum logout?
Yeah. And that's basically just the one of the video, the optional one.
Yeah, that's right. Find minimum rotated sort of array.
So save a piece of time coding, I think, and copy and paste that. I can't remember.
Yeah, I actually didn't do this one. So if you wanna, would you wanna share your solution to that one too?
I mean, probably just find it.
Oh yeah, just be like your search, your find pivot. Yeah.
It's Find pivot, but then it has to, since it turns in the actual value, it goes into the array and it's also the plus one.
Okay.
So it's the same thing, same idea.
Yeah. It's just
But you return like the actual value. I give you one.
Java. Oh, Java.
Bro, you gotta switch to Java, man.
No,
The-
dude.
The new wave.
I know everyone's using Java this year. Everyone was using
Yeah.
Python.
I mean, Python's so good.
Yeah.
I'm too lazy to learn Python.
If you know Java, Python should be pretty easy to pick up.
The psychopath needs Go. Don't
Oh,
they Go as like a language
God.
on there?
They do, yeah, I'm pretty sure.
Do Go.
Bruh.
I'm gonna use JavaScript.
PHP.
Racket, what the heck is Racket? Elixir.
Hey, Eric likes Racket. Give us a Racket solution.
Dart.
I haven't even heard of Elixir. Erlang.
You do it type. I guess it's just JavaScript. But
Yeah.
probably have it.
Yeah, it's like the same as Java.
Where's my ARM assembler?
No, dude. No. Yes, this is basically, this is like the same as your pivot. You're just changing what you're returning there.
Yeah.
Take it off the script and make like an CSUS file. Like an API to give the solution.
So
Yeah, how
Solution.
do it actually call it?
Solution not get. Okay, well, that's it for the weekly problems. I guess now we can figure out what category we want to do next week. And we could do like a problem together of that from that category. So done 2 pointers, sliding window, binary search. So next category could be linked list. We haven't done that yet. Yeah, how do we feel about doing linked lists for next week? Viewed?
I think that's good.
I think yeah, I think trees are
Wait, Decode has a fire sale? What is going on here with what is this?
oh I can't hold on, I can't see that. Oh damn.
It's the same exact words. Yeah, that's true.
Oh yeah.
Yeah, it's been that price for like 6 days.
Yeah.
Feels like a fire slider, like other way.
I don't have the fire sale.
What if you find it on Pirate Bay or something?
God. Torn in neat code. Okay, let's see. Find easy, perhaps.
Or a classic one.
So let me some easy ones.
Easy.
Middle of the list. Like a. There's some like easy medium-ish kind of thing.
Hog.
Reverse the other. Oh yeah, you can do reverse link list and do recursive.
Oh, I don't know if I've done that recursively.
But yeah, doing a recursive, doing like any problem recursively is like.
Not
You can do
fun.
iterative.
Yeah,
It-
iteratively
Is there
comes
like
much naturally, much more natural than
Some problems,
recursive.
some problems.
Yeah. Are we doing this in Java? We have to vote on the language. How many Javas we have?
Let's see, let's see.
C.
that's close enough to Java?
All right. I haven't coded in Java for a bit, so we'll see how this
No,
goes.
no, no, dude. Stick to Python.
Nah,
Stick to
dude.
the language you're best.
Shit, all right.
Yeah, it's fine.
JavaScript, it's like kind of in between Java and Python.
No, the syntax is terrible. But like,
Yeah.
What syntax? There is
There's
no.
yeah, with Patrick Claire, but like,
Yeah.
we'll call it. I mean, it's okay if like when you're trying to get to web development.
JavaScript best for with its inherent asynchronicity. You know, when I was like first doing it, I was like, oh, this is asynchronous. Huh.
Yeah. Not used to dealing with that for sure.
How did you get this problem? Did you find it on the?
I just found it on, it's just on Code under linked lists. Where was it? Middle of linked list. Oh yeah.
Have you done this problem before?
I think, isn't this like the turtle and hare algorithm or whatever?
Yeah.
Yeah. Yeah.
Do the reverse link list?
Why you gotta do this to me, Chris?
I mean, I feel like if we do a lot of these like using recursion, then we can kind of like transition to like.
That's
the other
true.
stuff.
Yeah, for like
dynamic
trees.
programming.
Yeah, trees.
That's the tortoise hare solution to this one.
Yeah, how would we do that? And so the idea of the tortoise and a hare solution is that you have two pointers, one that moves twice as fast as the other pointer. So you have like a fast pointer and a slow pointer. And so you iterate them through the list. And because one of them moves twice as fast as the other, it'll get to the end of the list at the same time that the slow pointer gets to the middle of the list. Yeah. Hare tortoise, hairy tortoise. It's really cool. I think you can also use it for detecting cycles in a linked list, right? Yeah. Yeah.
The 2 pointers catch up to each other. Yeah.
Yeah.
Cycle.
Yeah. Okay, reversing recursively. Oh, gosh. Here we go. So I'm guessing we want like a previous. How do I want to do this? Normally I'd have like a previous and a current.
Oh, we're doing this one, not the.
Yeah, Chris wants to do.
Perfect.
So we're doing this recursively.
Are you gonna use like a helper method?
Yeah.
Well, I mean, it was recursion, you should need the ultimate for this one. It could be done with like, that one can be done using, you have to have the base case first, so what's the base case for all that?
Base
Yeah,
case
what's the base case?
cur, if not cur. So we've reached the end. Not cur. Then we return previous. Otherwise,
What's this one? It's probably.
reverse this list.
Well, like, I understand you do this one is you have to add that and an extra argument. The actual,
So
function.
would that be the current?
For previous, yeah, you have like a head and previous, right?
Okay.
And like previous is gonna have a default value none, right? Because it's not gonna have like it's not gonna have anything on it.
Yeah.
And then like as you like you go every cycle, you're gonna have to like point like your new head is going to be here, like if the next value, so like you have head right there. You have to go like you go next line, like next or something like that, or you want like NXT is equal to next.
So then you're like storing that temporarily, and then that should be the same.
You have your current head pointing previous value, so you should have your head dot next equal to previous.
Next. So then it's like the same as the iterative approach from
Yeah.
there.
So now at the end, call it. Actually, so I think at that point you just do like return self dot reverse list. And then your head is now going to be your next thing that you just pointed at, and your previous should be your head.
Okay, I see how that lines up with the
I
iterative
think
approach.
that works.
And then that should return previous. Okay,
Oh, yeah, return previous. Yeah, I think actually, yeah.
right? I think.
Your
If it's not
previous
previous, maybe it's not
parameter.
Oh yeah, you did NXT for head dot next.
I think your previous parameter should be using equals instead of colon.
Oh yeah, that's
That's a type, isn't it? Yeah. Okay.
Yeah.
Whoops.
Your indentation, bro.
I'm indented, bruh.
Your I think your first if statement right there. See how it's kind of off. Yeah.
Java's the better language right there. There we go. Nice. Recursion. That wasn't too bad.
Yeah, no, all the acceptance.
I just whenever
Wait, so-
my confidence is lacking, I go to this problem and just do it like in 30 seconds.
Wait, so what's the runtime and space complexity? Because I think the space complexity might be different compared to the
Yeah.
iterative
So now you're
approach, right?
placing calls on a stack, right?
Yeah.
No, but actually, this one's a tail, what you call it, a tail end. So it's a lot less than its own stack. The last function that you're calling is a
Oh.
Python doesn't have tail recursion.
Does.
It doesn't have that optimization now.
Why does Crovitz teach it with it?
I've never taken Crovitz.
Yeah, I know. When I took Krovitz, like he was teaching tail recursion, I was like, Python doesn't have tail recursion optimization.
Well, if it's written in a better language, it is.
Yeah. Yeah.
Yeah, let me just pull it up real quick. We can go through the documentation together. That'll be fun.
But yeah,
Okay.
then like the space complexity would be O of n then.
Yeah.
For every node you're passing through.
Hmm.
For this solution, I think like the iterative one would be probably like more efficient.
Yeah.
But I mean, I guess if you don't know the size of the scale, just use that.
Yeah. Yeah.
That was a pretty good problem.
Sweet. All right, can do middle of linked list next.
Shows your heat.
The tortoise.
That's
Let's see. It's kind of bad.
the other one. Yeah, first one. It's the other one. That's the year that.
I haven't been on the grind because I have no motivation now.
Yeah, you already secured an internship,
Yeah, there's
bro.
no reason to be on the grind.
Hey, gotta be consistent. Gotta stay sharp, man.
Still the president. Still the president.
Okay.
Well, I guess you'll never know. That's too bad.
Oh.
Oh, I shouldn't have reloaded.
Yeah, you had it.
Don't look at my contest score, dude. I suck at the contests.
When you get.
I've attended.
That's when you find out.
Bro, you need to do more hards. Holy.
Oh, I've actually done more than that because I used that knockoff.
You can have the hard and
Oh,
Yeah. That's what exactly my thought process. Like if they ask me how hard I'm walking out, there's no way.
Honestly, like, I
No.
know they asked you, like, hey, what do you want?
They just asked me a medium or two easies and a medium.
It's usually like, yeah, there's like an easier two and then like a medium at the end.
Yeah.
If they ask you a hard, they don't want you.
No.
Just know that.
It's like, I've gotten like super close to solving cards and I kind of like trying to think how the solutions figure out and I'm like.
It's
but I-
always like some stupid math, like trick. A lot of
Yeah.
times, like some of the really stupid like.
Yeah.
trick.
I get
Yeah.
really close by missing some optimization on it and I figure it out and I don't lose motivation to finish it.
Mhm.
It's like, well, now it's not me.
I'm gonna put one hard by myself. Hey, that's
hey,
hot.
Stenan, should we go over like the problems we should do next week?
Let me see what percentage.
What was that, Daryl?
Should we go over the problems that we should do next week?
Oh yeah, let's do
Pick
that.
up, pick them out. Yeah.
Good idea.
We're grinding in August. Look at you.
Yeah, I got that's
Internship season, that's it.
yeah, it was literally internship season. That's why
You can tell.
You can tell. Yeah, that's when I was doing so many apps, man. And then that's when I got my offer and we're done.
Dang.
Okay. Well, we did reverse. Can do merge two sorted lists. That's a pretty good one. Merge sort.
LRU cache.
Oh yeah, I like that one.
Yeah.
Yeah, let's definitely do that one.
No, it's because
Yeah,
that
I know.
actually showed up during my interview. It wasn't specifically LRU, but it was close enough.
Yeah, it gets asked so often that they get it. People just know it now.
Yeah, I would like have that one memorized pretty much now.
Oh, wait, yo, design circular queue. Yo, that's so relevant for CS 130. Because that's actually like one of the questions like uh the professor wants you to like, implement two methods that work for a circular queue.
What is
Yes.
that?
Oh god, I hate those are like designs.
Yeah, it's like system design.
Bro, this is just it's data structures, man. It's the
How
data
many
structure
methods
part.
they want you to define?
DSA.
6?
Come on,
All right, we'll send it. We'll do it.
sir. Why'd they capitalize it like that? Bro.
Wait, honestly, hold on. If we're doing wait, can you go to like the actual blind 75 list? Because we're doing it based off of like
Oh, that's me code all. Yeah, we should prioritize 70 blind 75 for sure. So we'll do merge two sorted.
At this point, yeah, honestly, we just do it a hard so because even if you don't even know, even if like
Yeah, this guy's a god. He's
yeah, you're good at this. No, it's like what? Like how many problems? Like we just have to like one part of the category. We don't have to learn it. Just know the strategy behind it.
That's
One part.
I think
It's hard for like 3 hours.
Pretty supposed to spend like 20 minutes on problem. If you can't do it.
Hey, Steadon. So, just curious, did you ask Professor Gordon about the ICPC, or did you?
Oh, so he moved his office hours on Monday to Wednesday, and he usually has office hours Monday, Friday. This week they're on Wednesday, Friday. So because of the barbecue, I'm gonna have to go on Friday and ask him.
Okay, all right.
Yeah, I was like, really, the one week I want to meet you, he changed office hours. So yeah, Friday I'm gonna go now.
All right.
Yeah.
Like
Dude.
some random new some random function you just know exists in it.
Yeah. There's just let me
This shit expires.
Merge case sorted list.
Not super hard to solve. Probably getting to solve in time.
Oh, yeah, no.
Oh, how would you do
it's like
that?
Time complexity issue too, right? Yeah.
Alright,
Do it in O-advantage.
we wanna do this one? This one sounds scary, or for the.
Yeah, no, how would you do this?
Better be optional.
Yeah. It'll be optional, sure. Feel like making yourself cry, can do this one.
Let's leave it for hours.
Yeah.
It's actually how it's solved, so like.
We can condense all of this, that's sorted, then turn it into.
Oh, you know what? I think what you should use is a priority queue. And you would just hold a reference to the heads of all of those lists. A priority queue would work here. Right? You'd use a min heap. Maybe store like a tuple of like the current value. So like the current value of the head and then the reference to the head. Right?
Mm.
So I think a min heap would be used here.
Alright, we'll add it to the list.
Some easy one.
Yeah, let's get some easies going. So we got merge to sorted. That's an easy.
Bro, that's an extension for I don't know. No, that's like the precursor to merge case ordered list.
Yeah, exactly.
Yeah.
List cycle, that's a good one.
A merge case.
Tortoise hair. Yeah.
Is it maybe you could use a different algorithm.
Could you have this one that's efficient? It's like, could you use one for this one? It's like.
I already
like,
did this.
I
You said your
I've
code,
always
man.
used the.
The only ones I've ever seen for this one are like the tortoise and the
Yeah. Oh. Yeah, I
I might
guess
try to use a
then
graph
you're
algorithm.
using more space, but yeah, I feel like that would work too. All right. So we got two easies, a hard, and a medium. How's that
Wait,
sound?
do all nodes like objects have identification besides the value?
Yeah, so you could, yeah,
Like I can put like a 5 nodes that it would be different from like a different node that has the same value.
yeah.
Okay.
Yeah. Alright.
But so if you use a set, how would you know when it ends? Let's do that. Yeah, no, I know that part.
What if, yeah, there isn't a cycle? That's,
But what if the list is extremely long? What if like it's a really big circle? Yeah, but like if it's such a big circle where like run out of time. Because like if you have like a linked list node for like 1,000,
yeah.
right? Even if it is linear, but like a million or something like that. I don't know.
Yeah, because
I
I know.
don't think you can't go any faster than ON for cycle detection. I don't think so.
Yeah.
Unless you have reference to the tail, but the tail's unknown
How big
here.
is that? How big is this at the bottom? Fucking Christ. Never mind, yeah, I know. I was like, okay.
Yeah, that's a bit.
Well, that's like linear. The follow-up is.
I wouldn't try
I think the.
recursion here.
Oh, really?
Because the follow-up has to be constant, which is the slope factor.
Oh.
That's not you.
You're looking up solutions? What is this?
Whoa.
I'm just
You're
curious.
already
I'm
cheating.
curious. I'm not doing
I'm just
anything.
kidding. I'm just kidding. Everyone does that.
Like that. Picture what you know, it's slow.
Sad. Yeah, I think everyone knows slow fast.
Actually, if anything, I just want
Hey, no, try. I'm thinking of trying using a union find. That's a data structure that I learned a while back.
A what?
Union find.
Union find?
Yeah. It's you can use it to find detect cycle detections in graphs specifically. So like you can imagine a linked list is essentially a graph as well.
I forgot what you care about that already.
Interesting.
And you can check, if you check the tags, it'll probably tell you what algorithm to use in the description.
Yeah.
But it will probably tell you by now, but.
Oh, there we go.
There it is.
Oh, hashtag.
Hashtag. Let's see.
It's a cycle too.
Where'd you see that?
I just saw it. Like, probably the same thing. I think I remember now.
Yeah, it's probably the same tortoise and hare. All right, I've got like 15-ish minutes. We could do this problem. Get an intro to how the tortoise and the hare work. So we'll have 2 pointers, slow and fast. I do like this. I might screw some up, we'll see.
Bro. If you do that during
This
your
is the
internship,
Python way. I'm pretty sure.
you do that in your internship, bro, you're gonna get smacked.
No, dude. Yeah, exactly. They know you're a real Python programmer if you do it.
That's like unreadable. Like they're gonna be like, what is this?
Nah, dude.
That's
That's yeah, one happy
Oh
family.
my gosh.
This is the way, Daryl. You're a boomer.
Oh my gosh. You're not wrong.
Well, fast.
I'm using Java. Everyone everyone calls Java a boomer language. I mean that's the same thing with C and C++.
Will you check between them first, like so it slows it faster?
Yeah, that's right. Thank you. And so we have to check because fast is moving 2 nodes at a time. We have to check that fast is not null and fast dot next is not null.
Is that, if you check first, looking at, fast can't be equal to.
Oh, that's a good point. Yeah.
And we slowed right?
We, you can get, I just move your score, just set fast equal to slow down.
Yeah, let's do. No, so I can't do my cool syntax. I'll do this instead. This is probably even worse. You like that, Daryl?
Bro. No, I think the way that you assigned your variables was fine though. I don't think it makes any difference. Because you're only updating the reference in the variables. But do it.
We'll try it out this way and see if that works. So we're moving slow 1 node at a time and fast 2 nodes at a time. Here's where we check if they're equal.
Make it more Pythonic.
Wait, how are they gonna ever be equal?
More Pythonic. All right, hold on. I gotta make this more Pythonic for Chris.
Bro.
Oh, that's beautiful.
Bro.
Look at that. Look at that.
Well, you reduced it by 1 line. Now, and it's unreadable.
Oh my God. Like, how do I even? I don't even know how to do that.
In the if statement,
Like-
if slow dot next. Slow dot next is equal.
We don't need that. We don't need this. This is the middle of the class line.
You need to
Oh,
check.
Yeah, what am I doing? Oh my God. So
You just I think you would just return
Bruh.
slow pointer.
I'll just on autopilot. Okay.
I see tortoise and hare, I just think it's like.
Yeah, literally, that's, yeah. Okay, so we're just returning slow at the end because once fast is at the end of the list, slow will be at the middle. So then we just returning slow value.
Well, do you have to start next?
It says something about the second middle.
Yeah, so.
No, I think you're good.
Fast next, fast next, fast
I think you're good.
Well, fast next.
Yeah,
I'll find
No.
the next.
Yeah, you're
Oh.
good.
Check the extra.
bro, there's too many nexts.
Next JS?
I think it's.
Next year. What do you?
The problem is that you have to return the second. If there's even not there, like in the second one.
Wrong answer. What is this?
So that is, so by the end of the operation, fast on next is null,
Hmm.
then you return it to slow one time.
Okay. I see what you're saying, so it's even.
If not fast next.
We do, with the Python support, like the in line, all that. Every
No, yeah, return, you can do return, slow dot next, if not fast dot next, else fast dot, or just return slow. Yeah. If not fast dot next, else just add else slow, or else slow.
Bro, this is so unreadable.
Bruh.
Arc and then the two off nodes that.
Oh.
This is,
Yeah, that's the ternary operator in Python. Yeah,
It's beautiful, isn't it?
this is, we gotta get this down to one line.
Don't make it, don't you did it right, you just go straight line. We'll go slow for slow, actually, let's see the while, after the while loop,
Yes.
go back, up. Go up the line.
he says.
Yeah, one line, it's a while.
Bring it up, bring it up. Bring it up.
One line.
Like that? Oh, yeah. And we just gotta stretch it out. This is the way. This is great.
Alright, you guys are just trolling too much right now.
Oh, I can't see if I see.
Interviewers hate to see that.
Oh my god.
Is this what they mean by clean code?
Combined.
It's less lines, I think it's better.
Oh god. Yes, definitely. If only that was the way it worked.
Did you put a semi?
Yes.
Yes.
Bro, what is this?
Yo, really like that?
Well, still gonna go.
Yeah, it's still why
Hey, but
It's still wrong, bro.
No syntax.
syntax is great. Spot on syntax.
Now let's debug this.
Oh.
We don't even know where we're at.
Yeah, debugging this is not gonna go well.
Everything's just saying. All I fix fast and next.
Fast next, fast next, fast next.
Is the return statement flipped?
Yeah, return slow, if not fast on next.
I think,
Fast
um,
next. Or if not fast on next. Just
Just throw next in there.
The interview will love this.
So we're one ahead.
How would it just walk fast like that?
Okay, that's what I thought too.
Oh yeah, while slow and then while faster, yeah. Yeah, that makes sense, yeah. You have your syntax here.
Oh my god, damn. What? Oh god, what just happened?
Three tabs.
Yeah, I've got like a billion tabs. Oh, come on.
I think you want to return slow dot next, right?
Right? Is it not clear that we are?
Yeah, but like, if
Obviously, we are.
Obviously.
no. For
Return.
the next statement, I think you actually want to return slow dot next instead. I think you got it
Okay.
reversed.
We got one.
We got one, boys. We got one.
We're missing one.
Should be one more to the right.
Yeah, one more.
Slow down next on next.
Is it an,
Bro, it's too many next.
yeah, it's an even list.
Turn next.
A dummy node?
Yeah, online node. Because we're starting at index one.
I think there's
Yeah.
an error on line 12. Right now.
You know, I think you're right, Ryan.
I think there's something wrong with line 12. What's the return?
What-
If, fast ends on the next pointers.
Yeah, then there should be.
No, you should, I mean, I've done this thing, like, the whole thing. We haven't done it beforehand.
What would we do with the dummy node?
It's
The
like right now you're starting from head, which is index one.
Mhm.
So what if you start from like a dummy node that points to head, that's indexed in 0. Maybe that's why it's just the index messed up.
Oh, because that's why we're like one off
Yeah,
down here.
so you say it's like make a variable like dummy looks node, then make it point towards then make it like -1, make it point to head.
Okay. Let's do that.
Wait, what?
Yeah.
And then
Then,
slow and fast equals to
oh, that's right. What am I doing?
Like everything. You can just put -1 and then comma head inside the.
Bro, this should be an easy.
Yeah.
Whoa,
And then-
how are you taking so long?
Perfect.
For sure.
They're all just gonna have an aneurysm. Right? Can I do that?
Bro,
Wait.
I
Wait.
think I'm gonna leave. I'm gonna leave now.
Doesn't even fit on
You're
my.
trolling too much.
Ultra wide monitor.
Yeah, seriously.
Using the spaces, oh, I hear you.
Oh.
Invalid syntax.
On what? I think it's on line 10.
I think you're right. Okay, fine. That should work though. Oh, maybe not.
You're being too fat on it.
Damn.
I see right now, there's spaces between the slow equals fast, that's, like, I don't think the calculation space.
That's suboptimal.
Yeah, suboptimal. Dude, it's not.
Yeah. We're never gonna get this. We're so focused on the syntax that we can't do this problem.
Alright, guys, let's just get the question right.
Test cases.
Which case two?
Is it because you, they should be pointing to the same. There. No, but they should, so like if you assume that you have one element,
Mm-hmm.
we wouldn't have to while loop because fast on next. Then we
Yeah.
return.
Maybe we.
How about we fix the lines, bro?
Come on, guys. I thought you were. I thought you were Python programmers.
Nah, I use Java.
Java would explode.
That would not be pretty.
Well, you do have to have a fast dot next because you're changing the pointer to fast dot next. Why? You do have to.
That's true.
We only got to check fast on next.
Well, like.
Because if you, so
That should be it. I don't think you even need a dummy node.
in the worst case.
It's kind of unnecessary. Bro, okay, just remove the line above. Remove that entire line. Set slow and fast ahead.
You want saying this?
Yes.
Okay.
Well, fast dot next and fast dot next. Twice. It's still.
No.
That's logical. That's a logical move right there.
No. Just get rid of the have while fast and fast dot next.
So back to the original.
Yes.
Oh no.
People have bad advice here.
And get rid of that. Just return slow.
Think of all this extra code.
I felt cool with all the one-liner.
Bruh.
Wow.
Bruh, you guys like overcomplicated everything like
Bro,
I wasn't thinking about code. I
I
was
spent too much time thinking about Python.
that was, yeah. I think
Alright, now
I
you
feel like
can
I
put
learned
it
a lot
on
from
when
that.
I didn't know you could do the semicolon thing, so that's actually, that's good.
You should never ever use it.
Yeah,
Bro.
I'll never use it, but you
Wait,
can
so
use it.
What?
Oh my gosh.
No, return to slow down next.
Let's see.
So there's so an even number of goods.
Yeah, let's go.
I have to draw it out, right? Or it's-
So the example two.
Is there an even test case?
Yes.
No, it's already handled.
Disable-
If
Oh, yeah, it already does it for you. It's the second one.
Yeah.
Anything over slow lines is gonna be the default, no. Yeah, no, yeah.
So we started at one, first iteration, we slows at two, but then we pass it at three. Second iteration slows at three, but fast at five. Oh, okay, so
Yeah, it just lines up. All right.
alright now. Can you post the questions on the Discord?
Yes. All right, that's it for this meeting, y'all. That was a good sesh. Thanks for coming, everyone. See you same place next week.
Bro, I missed out. I should have been there on person.
It's great here.
Yeah, you're missing out.
Good time.
Vibes are high.
Yeah. I didn't expect Chris to be there. What the heck? What the heck?
You would have come just because Chris came, but not.
Yeah, no, dude. I haven't seen him in a while. Like,
God.